So thanks for joining. So the agenda for today, do a little bit of introduction and definitions of the topics we are going to discuss. We're going to talk about specific benefits of leveraging the industrial Internet of Things. Then we're going to talk about some of the challenges that companies run into, OEMs in particular, in overcoming some of the technical barriers, whether that's expertise or connectivity can be an issue, connecting to customers. How do we have those conversations with your end users, and how do we overcome concerns there? Then I'll talk specifics about the RAMIC solution that we've been providing, and then something we call the Uberization process, and that will mean more as we get some definitions underway here. Just by way of introduction, wanted to mention who we are. My name is Tom Craven. I am the VP of Product Strategy for RAMIC. My background, I've been in industrial controls all of my career. Spent almost 20 years with GE, came over to RAMIC a little over a year ago. But RAMIC has been doing cloud-based monitoring for nearly a decade. Now, of course, it wasn't called that 10 years ago. But today it's called cloud-based monitoring or the Internet of Things, and we'll get to the other definitions on the next slide here. But whatever we want to call it, we've been doing it for 10 years. And what we have been doing is collecting data from remote sites over the Internet, or early on it tended to be more over cell modems. We do both. But we collect data from remote sites, we store it on a secure server, and we give customers secure logins to get at not just the data, but to detailed, customized reports so that they can see what's going on with that equipment. Along with that, in many cases, there's also a secure gateway so they can monitor online with PLCs, et cetera. We'll talk about that piece of the solution as well. There are a lot of widgets out there. Everywhere I go, I run into yet another company that is in the industrial Internet of Things and doing cloud-based monitoring, et cetera, et cetera. What I find out there, there's a lot of people providing a device or some piece of the puzzle. One of the things that's unique about what RAMIC is doing is turnkey solutions. So we're not going to simply give you a bucket of parts and widgets and say, hey, go build your solution around this. We deliver a full functioning working system. So we will help you get all the way to your end goal or your intermediate goal. It's typically a path, a continuous improvement path that customers go through with the Internet of Things. So we can get you started for a easily measured cost, and we can be there as your system grows and changes in years to come. Everything is customized, so what we deliver will look like, just as if you've done it yourself, with your company name, logo, whatever screens, standards you want in there, types of reports, etc. I mentioned hardware. We are hardware agnostic in that we don't really care which type of PLC you're using, or in some cases we'll pull data off an operator interface device. We can use multiple types of cell modems and Internet gateways. So some definitions. You hear a lot about the Internet of Things. And the Internet of Things, essentially the Internet has been known for many years as a way of people connecting to information. The Internet of Things is an acknowledgement that more and more devices are being connected to the Internet, whether that's a thermostat in your house, or a generator out in the field. There are all sorts of things that are connected to the Internet these days. The industrial Internet of Things narrows that scope specifically to the industrial world. So when we talk about maybe a packaging machine or a generator or a water lift station, et cetera, those would fall into the industrial Internet of Things as opposed to some of the household type uses. The industrial Internet is another term that pops up. That's actually coined by GE, where I used to work. it's essentially synonymous with the Internet of Things. The industrial Internet of Things may have grown out of that term. I'm not really sure. But for all practical purposes, they're synonymous. The other synonymous term is Industry 4.0. That one came out of Europe, I think Germany specifically. That's a reference to the growth that has gone on in the industry, the automation world, if you will. Started with Industry 1.0 with simple mechanization of production. Industry 2.0 with electrical power and mass production, and I think of that as the early days of the automotive industry. Industry 3.0 is factory automation, or you can think of that as PLCs and other intelligent automated devices. Industry 4.0 is then defined as the Internet of Things. The other thing I'll say about Industry 4.0, Europe's driving that term, but it's rapidly being adopted in the U.S., and that seems to be going forward the term you're going to see more and more, partly because some of the European community is adopting or writing standards around Industry 4.0. And we will show you a little later in the presentation an Industry 4.0 certified communication standard that we've adopted. Okay, so definitions. What do we mean by Uberization? Obviously, it's a reference to the company called Uber that most of us are familiar with. Uber has really made a disruptive change in the taxi cab or transportation industry in the past few years. And there are a lot of opinions on Uber. Some people love it, some people not so much, but you can't deny that they have made a dramatic impact in their industry. And what have they really done? You know, what they did is they took a smartphone app, they took internet connectivity, and some expertise applied to their industry. And what they've done is they've drastically simplified the process, in this case, the process of taking hiring a taxi or hiring a ride to a location. They've reduced the cost, both for their internal cost as well as the cost to the customer, and they've dramatically improved the user experience. And some of the things that are popular, we did a little fairly informal survey of Uber users, but there are many things that people like about Uber. Less expensive, you don't have to use cash, you don't have to make a phone call, and we'll get into some of the details of how they've changed the process. You don't need paper receipts. These receipts get emailed to you. You can get details on the driver and the vehicle that's coming to pick you up, including when it's going to arrive and when you will arrive at your destination. So it's a lot of information at your fingertips. So how do we apply the Uberization concept, or what Uber has done? How do we apply that to the industrial Internet of Things or to OEM applications in particular? If you think of it from a user experience standpoint, it really is information at your fingertips. Operator interface panels, I actually was the product manager for the Quick Panel line or Quick Panel Plus line at GE before I left. And you know, those are valuable, important pieces of equipment. You need some sort of local touchscreen in most applications. But if you think about what an operator interface is being asked to do, you're getting a lot more trending data, you're getting alarm data. And if there's a critical alarm on your piece of equipment, do you really want to run out to the factory floor or to a remote location to see what that alarm is? It would be much easier if you had that in a user-friendly format on your smartphone. Came in over an email, maybe with a tie-in to a dashboard to show you exactly the current state of the machine and put the alarm history on there as well. All of that can be done on a smartphone app to make it an easier user experience. From a troubleshooting standpoint, if you think about when there's a problem or an alarm on a control system, or particularly on a SCADA software, for example, there's a lot of back and forth phone calls between the end user to the OEM, back to the software provider, and you end up with these long phone conversations that it's not the most productive way to troubleshoot the system. With remote connectivity, you actually can share the information much more easily with the subject matter experts. So whether that's the experts for your OEM support team or whether that's the support people for the control products or software you're using, there's ways to share that with specific people across the internet. And you have full control over who has access to which site and for how long. So maybe you open up a window for an hour or a day so a specific person can look into your machine and help you diagnose problems. Data flow. We still get people running around writing things on clipboards. And anytime I see that, I go, there's an opportunity to streamline that process. I've seen people writing data on a clipboard that's sitting there on their HMI screen, for example. Once we connect to a remote system and have that data on our secure servers, we can share that with your other information systems, whether that's an ERP system or a manufacturing execution system or maintenance management. All of those things we can tie into and automate that process, and we'll get to some of the specific benefits and how that ends up being a cost saving for OEMs. For ordering consumables, a lot of OEMs ultimately make revenue off of selling a consumable item. There's a lot of chemical delivery systems, whether it's water treatment or maybe a car wash, some sort of seed treatment application that I'll mention a little more about. There's companies that make significant revenue off the sale of consumables. What we can do is automate that process. With remote connectivity, we'll know exactly when those consumables are running low, and we can automatically generate the refill orders and even the billing if desired. Quality and productivity. How do your customers, the OEM's customers, get more value out of the equipment you're providing? So some of the things we do along those lines is to track production and quality totals. We can look at the raw cost of materials and associate that with the end product. Also the energy costs, if we're monitoring energy, which is one of the things we do. You can tie the specific energy costs into the end cost of the product. You can compare settings between sites, help get basically shared best practices among your customers. You gather that information and say, well, gee, Mr. Customer, you realize, there's people getting better productivity than what you've seen, and here's how you get there, and here's the data to back it up. Diagnose common failure modes. You get a lot of anecdotal information that, maybe there's an issue with your machine, but it's hard to quantify. Once you have that remote connectivity, you can start to analyze that in a bit more detail. You can also see if there's common errors that your customers are making or maybe not applying the product as you had in mind when you designed it. These are all things that can benefit your customer. And you can also give measurable reports in terms of dollars, and I'll show you an example of that as I move forward here. But help your customers understand what their costs are, what the potential revenue benefits are of running more efficiently, those sorts of things. In terms of downtime, a lot of people implement remote connectivity specifically for downtime. There's a couple approaches to this. Reactive maintenance is, it's basically break-fix. Something broke, I want to fix it as fast as possible. Well, that starts with notification. So if you get an email or text that tells you exactly when something goes down and what the problem is, you can't fix it until you know about it. And so those remote notifications are an important part of that. And again, if we tie in a dashboard link or historical trend or alarm history, etc., on a smartphone app, you can get to the root of the problem much more quickly. And again, with the ability to go in and actually program the device remotely. Depends on the industry. I understand there can be safety concerns, but in many cases, people are doing remote programming or at least online monitoring. The PLC program can help you fix things quickly. Predictive maintenance, instead of waiting for something to fail and fixing it quickly, how can I eliminate the failure altogether? Classic example of that is simply monitoring motor current. If a motor is drawing more current today than it did a week ago for the same workload, then clearly there's something wrong with that system. It maybe needs new bearings on a motor, lubrication. Maybe there's an issue with the mechanical system. Maybe you're deadheading a pump into a blocked pipe. But if that motor is working harder, that's an indication that something needs to be addressed out in the field, and you can actually address that before it shuts down your system. Same thing with vibration sensors. If vibration's going up, that's a mechanical issue you can address. Temperature in many cases, motor temperature or other heat issues can be a leading indicator that something needs maintenance. When you do have downtime, we can give you drill down across maybe by product type, by site, by specific customer, maybe by climate. We often tie weather into our remote systems and track that as well. You can determine if customers are doing required maintenance on your system and how they're using your equipment. Are they running it at speeds that it was designed for? Are they using it properly? Once you know that information, it actually opens up some potential revenue channels, because some customers may be asking you for extended warranties. And if you know how fast they're running the equipment, and if they're running it within designed operating parameters, you can say, yes, if you're doing that, and yes, I can verify that you're doing the maintenance required on the system, yeah, we can give you a 3-year warranty. We're not giving you, we can charge you for a 3-year warranty. Same with service contracts. If you have the ability to assure uptime for your customers through this remote connectivity, through reactive maintenance and predictive maintenance, you can help them run better. Some OEMs will actually tell me, well, that's not really our job. No, but it's a sellable feature. It's a reason for customers to come back to you, and it's a potential revenue stream, because you can say, all right, you're running at this amount of uptime today. We can improve that for X dollars. So there's an opportunity to generate new revenue. I'll get to some specific examples here. So we had a customer that they coat seeds. So they take seeds, they coat them before they go into storage or go into the ground. And there's chemicals used in that process. The chemicals tend to be both very expensive and somewhat hazardous. And traditionally, these were mixed by hand. So the problems were quality, because hand mixing is not that reliable, hand measurements. But also the farmers that were doing this were being exposed to some fairly harsh chemicals. So we automated that system, or actually an integrator automated the system, but then we tied in the remote connectivity as part of this. We do chemical recipes for this customer based on the seed type and on environmental factors at their specific site. And because they have a very short application season for this coating, they can't afford to run out of coating chemicals. Otherwise, that's lost revenue for the farm. So what happened with this system is we put in an automated system to meter out chemicals from these little blue kegs you see. And you can see a control system there with an operator interface and controls. But the remote connectivity part of this is crucial, because what you see, all those yellow lines going different directions, what that is information transfer. This one is far more than simply getting a dashboard to see what a temperature value is. We're actually doing remote billing at these sites. We're doing reordering of the chemicals. We're automating that. We were sending email and text alerts when there was a critical failure, but eventually this customer came back to us and said, you know, that's great, but we all know people ignore emails, and sometimes these things are not getting followed through properly on the customer's end. They admitted it was their issue. They said, you know, if you could tie into our maintenance tracking system and automatically generate a service ticket, that would really help us out, because then there's a built-in process that it gets followed up on, and it's not just an email sitting in someone's basket inbox. So we did that, and it was fairly easy for us to do. So we frequently tie into these other systems, whether it's for maintenance or orders, billing, etc., inventory tracking. Genealogy is another one that came into this particular application. They wanted to know if there was an issue with a batch of chemicals, what customer orders would be affected. So if they ever have a recall, they can do a very targeted recall. So basically, we Uberized this treatment system. We automated the chemical measurement, so we have less wasted chemicals, less cost there. Vendor-managed inventory. These farms didn't want to pay for these very expensive chemicals by the keg up front. They want to pay for what they use. So it's metered out. They are billed based on actual usage, and then the remaining chemical is sent back at the end of the season. The user experience is improved partly because they're not exposed to these dangerous chemicals. Everything is sealed, so they don't have to do the measurement. And they don't have to spend the time measuring and mixing. So it's a much easier user experience. The customer information, as I mentioned, all these alerts are automated. The ordering is automated. And the quality is greatly improved. Now, part of that's through the control system, but the recipe downloads for specific sites are all managed remotely. We have another customer doing feed extrusion. And so what happens with this, extrusion can be a fairly complex process. What this extrusion process is actually squeezing the oil out of feed to process the oil. This customer they have sites literally all over the world, and they needed to reduce downtime. They had quality complaints from their end users at times. I talked to the sales manager at this company, and he says, you know, my customers will complain that they're not getting the quality that we had promised them, frankly. And he says, I know what's happening. They're speeding up the production. They're trying to make as much, produce as much as possible, but they're sacrificing quality for speed. And he says, I can have that conversation till I'm blue in the face, but I need to be able to back it up with data. So we're connecting to their remote sites. We are collecting data so that that sales manager can come back and say, okay, look at the data. This is what other people are doing. They're running within these recommended parameters, and they are getting the quality that that they need. And they also have information to talk to a particular customer and say, we know exactly how you're running the equipment, and this is exactly why you're not getting the quality. So they are using it both for improved quality as well as reduced downtime. An interesting conversation, because when we started talking to this company, we talked to them about remote monitoring, because that's what Ramek's always done, is remote monitoring. We talked about cloud-hosted data. We talked about web-published reports. And they said, well, that's all nice, but that's really not what we're looking for. All we really want is a smartphone app. And I said, well, that's interesting. What's the app connect to? Well, it's going to somehow connect to these remote sites. And the way they had envisioned doing it was not particularly secure. We'll get into some of that in a minute. But ultimately, they just wanted an app. Well, what Ramek delivers is an app, or it can be. But we also have the back end to support the secure remote connectivity and all of the data. And many of my customers, I don't want to say they don't care about that, but that's not what they're interested in. It's not the driving force. But ultimately, that secure connectivity and the data collection is a critical piece of supplying this remote data. So in many cases, I promote this simply as a, hey, we sell apps, because that's what some customers are certainly looking for. So we were able to come back to this customer and say, yes, we have an app for seed extrusion. And you can tell the same thing to your customers. You know, you can have an app for whatever your OEM customers and whatever your end users are looking for in an app. We can deliver that, customized with your specific company logo, colors, whatever format you want, and certainly whatever information you want to put in there. I'm going to talk a little bit about overcoming some of the commercial and technical barriers. The biggest barrier I hear from OEMs is, well, my customer will never let me do that. They won't allow the connectivity, or we don't understand how to do the connectivity, or we tried it and it was a pain to manage and people pushed back, et cetera, et cetera. I'm going to talk a little bit about the security, actually about the next half a dozen slides are around security, and then we'll get into these other aspects of the in-house expertise, engineering bandwidth, budgetary constraints, and measurable ROI. But security is the first piece. So how do you overcome, as an OEM, how do you overcome the objection to the end user saying, well, we just, we would never connect over the internet, or we tried it once and we won't allow it, et cetera. Let's start with talking about the concerns by the end user. Part of it's fear of the unknown. There's an assumption that if you're connected to the internet, then anybody can get into your system. I'll address that one in a minute. They're certainly concerned about unauthorized access to the network. Maybe they would be okay with you connecting to your machine, but they don't want to open up a gateway where people can come in and browse their network. They're concerned about the time and effort to oversee and maintain that connection. If you're asking the end user IT group to get involved, that can be a challenge, getting their time. So we avoid making the end users go in and make IT changes, and we'll talk about how we do that. And then, of course, there's safety concerns. If somebody can get into my equipment when it's running, depending on your industry and application, that could be a very significant safety concern. The fear of the unknown, can anybody get in and access my equipment? Well, first of all, you don't ever want to put a public IP address to access equipment. And in fact, this company I've mentioned that just wanted the smartphone app, that's what they were going to do. They were just going to put an IP address out there so that their end users could take their smartphone, type in the IP address, and get there. Well, if it's that easy to get there, anybody else could. So you don't ever want to use a public IP address on your equipment. So we want to restrict access by using firewalls. We use SSL certificates. We also use private cellular networks in some applications. We also use data encryption. So the idea that, can we securely connect to remote sites? I like to use the example of online banking or credit card transactions, or some people telecommute. We do secure connectivity all the time. It's not really a question of whether the internet can be securely set up or secure to an acceptable level, because most people are willing to do online banking, and that's very critical information. The question is, can you as an OEM or an end user be assured that you truly have a secure connection? And we are experts in that secure connectivity. We can help you with that. We can get you over that hurdle, and I'll get into how we do that in a minute. Also understand the risk-reward. There's a trade-off. Some people would assume that if you have no connectivity whatsoever to the internet, then your data is safe. I was actually at a presentation put on by a former White House cybersecurity chief of staff. I don't recall her name offhand, but she worked under George W. Bush in charge of cybersecurity for the White House. And she said that zero connectivity is not really the answer, because what was happening was people were just trying to do their jobs, and they had access to secure documents at work. And there were times when they had to go home at night and still had work to do. They were taking photos of their computer screens with secure documents. And obviously that's a major security breach. But she said we really hadn't given them a choice. So you have to have ways for people to get data that they need, and zero connectivity invites workarounds. So a lot of companies that tell me they won't ever allow secure connectivity will then turn around and say, well, yeah, we occasionally, plug it into the network, plug it into a public address without any added security. So that's not a secure way of doing it. One of the things that, preventing unauthorized network access, you need to properly manage users. And the diagram I have here is often used with VPN systems. So we have 3 users across the top. They need to get to any remote site. So what you have at each site, anybody out on the internet could get there if they have the username and password. And that's a typical VPN system. The problem with that, there's a number of problems, is trying to maintain unique access for each user at this site is a problem, because it's hard to manage that. You actually have to, in these scenarios, go into each site and define usernames, passwords. What generally happens is you have one username and password that's used by everybody in the company. And if Bob, for example, leaves the company, he still knows all the username and passwords at the remote site for this company. It's not a good way to do it. Yeah, so the issues are logins have to be created at every site. Deleting users is time consuming, so even if you had unique login for Bob, getting him off of all these remote sites would be extremely time consuming. So most OEMs end up using a single login with passwords that never change, and half the time it's the OEM's business address or phone number, or their name spelled backwards. They're not that hard to get into. A better, more secure way of doing this is to have a centralized server managing that user access. And so in this scenario, you have a server, in this case our hosted server, to manage those usernames and passwords. And if Bob leaves the company now, you can kick him off the day he leaves. You just go in, you delete his username from the central server, and he cannot have access to anything out in the field. You can also put in password expiration date. You can enforce whatever password rules you need, special characters, caps, number of characters, all of that sort of thing can be managed centrally. And I mentioned earlier, if there's somebody else out there that maybe a consultant, integrator, support person that needs access to a specific site, with the central manager, you can say, look, you can go to this particular site today, and it will automatically expire tomorrow. But for today, I'm going to let you in, and you can help me diagnose the alarms that are popping up on this system out there. So it's an easy way to grant access to subject matter experts without compromising long-term security. Role-based access, so you also can control who does what. Many systems are read-only. Many users are read-only, even if you allow remote set point control, etc. For some people, you can make everybody else read-only. In some cases, maybe it's okay to do an upgrade to the connection device, that gateway sitting out in the field, just routine maintenance without affecting the control system. In some cases, people will do software downloads to these remote systems. Set point control is fairly common. Actually, starting and stopping of equipment depends on the industry. If it's a high-speed packaging machine, you don't want to do that. If it's a pump in a remote water system that's typically starting and stopping based on a signal from across town, it not that big of a deal to have that same capability from an internet site. And so we see in the water industry, it's okay to do that remote starting and stopping. So we have the capability. We can disable it if it doesn't fit your industry. There is such a thing as data diodes that will allow data to flow in only one direction. I find those they tend to be very expensive, tens of thousands of dollars for a certified data diode. We essentially can act as a data diode, but when you talk about a secure data diode, that's a whole nother level that might be appropriate for a power plant or other applications, but often not the case, the average OEM. But it is available if needed. There are situations where you can say, all right, I'm going to allow remote connectivity, but I want the operator to have a button or a switch or something to turn it on and off, and that's fairly common. And in situations where you say, yes, I can do remote start-stops, obviously at that point you're dependent on local lockout, tagout procedures if somebody's doing something on that equipment remotely. A lot of people assume what we're talking about is VPN. We typically do not use VPN, and there are some specific reasons for that. VPN is designed to connect a network to a network. The problem with that is you have the potential to come in and browse that remote network. As I said earlier, the end user might be okay with you accessing your machine, but they don't want you on the rest of the network. So that's an issue with VPN. Local IP has to be willing to allow an incoming connection, and as I pointed out, then potentially anybody on the internet could get in and modify that machine or modify that network even. And in order to limit you specifically to access to your machine, the end user IT group has to configure the firewall and restrict access to everything else so that you can only get to your machine. Asking IT to do work, especially asking other companies' IT groups to do work on your behalf, that can be a very difficult, time-consuming conversation. If they're willing to do it, you're probably not on the top of their priority list. And so for those reasons, many OEMs have become frustrated and said, well, no, we can't connect remotely. So the other thing with VPN is you cannot have continuous connections to multiple sites, because if Sue, for example, has a VPN connection going to all these customers, well, guess what? She just put all these customers on the same network, and that's not going to fly. Partly because the way we typically, I say we, the way OEMs typically do IP management is have a fixed IP on their PLC, and they have the same one at every site. Well, that's not going to work on one interconnected network either. So you have IP address conflict. So rather than do VPN, what we do is device-specific connectivity. What we do is we put a device out in the field that will collect the data from the local PLCs or operator interfaces, or maybe we integrate cameras, but that data is pushed up from the remote device. We typically do report by exception, so we're not overloading the network and data usage, etc. But ultimately, the connectivity to our server is initiated down at this device. That means no incoming firewall hole. The data goes out rather than comes in, or the connection is from within the end customer site, and it's going to a specific server using SSL encryption and security certificates. By the way, I say SSL. TLS is the modern name for SSL. Functionally, it's the same thing. But we use data encryption and security certificates to eliminate any potential man-in-the-middle attacks when you're going across the internet. So your data is secure. This is known as a Trust One configuration. I mentioned with White House security and the Trust No One policy, or many factories will say nobody's ever connecting to our network. That's a Trust No One. Trust One says, yeah, there's reasons that I occasionally need data out of this system, but it's only going to this server, and then we have full control as to who logs into our server and has access to that data, and it's limited by customer, by specific site, by roles, etc. But the connectivity is going to a single network. It's not going to allow anybody else on the internet into this site except via our server. So some of the advantages of a hosted system: there's no public IP address, there's no VPN configuration, no incoming firewall holes, everything's encrypted, centralized user management. We do two-factor authentication as an option for the users. Full audit trails, so if somebody does go in and change a set point, you know exactly who did it. And everything is on Tier 3 level data servers. Many people are afraid of the term cloud hosted because they think, oh, it just means the data is floating out there on the internet. Our servers, our hosted servers, are in our data center. We have on our servers are located in a secure data center here in Minnesota, where our headquarters is. But they are our servers. They're not an Amazon cloud. They are servers we own in a secure data center that houses other secure servers, like from medical companies. So what you have is a facility with redundant power, redundant servers. We have automated off-site backup, so your data is protected. These other potential commercial barriers that I mentioned, I'm going to cover these after I introduce the Ramic solution. And the Ramic solution is basically what I described on the earlier slide. So we have a secure connection coming into our server from each site, and then we produce email, text notifications, hosted web reports, live dashboards, historical trends for all of these users, whether you're on a PC, a smartphone, a tablet. By default, everything is HTML5, so you could see it virtually on any browser out there. But more and more often, people are asking, hey, I'm going to look at this on my phone. I don't want to have to pinch zoom and look at something that was designed for a PC when I look at it on my phone. So what we will do is actually do smartphone apps, both for iOS and Android. And then the analytics are a huge part of this, as well as the connectivity to other software systems. Sycamia, I'll mention here. Sycamia is a company that does secure programming for remote devices, and that's another product line that Logic carries. We embed Sycamia within our products, so if you want to program your remote PLCs, you simply have to pay for the license. But depending on the architecture, we typically can pre-install the Sycamia software on our remote edge device. And Sycamia is an Industry 4.0 certified remote connectivity solution. And as far as I know, they are still the only Industry 4.0 certified system out there. Now, Sycamia, their solutions are very complementary to what Ramic provides. So they do the gateway functionality for programming. We do all the data logging, analytics, etc. So there's not really much overlap between our two companies. So we have a very good relationship with Sycamia. So with a hosted solution that we provide as a turnkey solution, the in-house expertise concern really goes away. We are the experts on the connectivity and the hosting. We're not asking the OEMs to become experts on that. So you're the expert on your equipment. You're the expert on what you need the system to do. But so we'll work with you to figure out, how we connect to your controllers, whatever you might be using, CNC, PLC, embedded, whatever else. We can help you get those connections going. But we'll manage the security for you. So we're not relying on in-house expertise at the OEM. If you have some expertise and you want to participate to whatever degree, some people do their own HTML, graphics, whatever else, that's fine. We'll work with you. But it's not a requirement in order to use our software. Engineering bandwidth is often a concern. People go, well, I don't know how many engineering hours I'm going to need if I go down this path. So it becomes difficult to cost justify. Well, again, since we're not relying on in-house engineering to design the connectivity system, we can provide a turnkey solution without tying up a lot of engineering hours. And again, if your engineers want to be involved, that's great, but it's not a requirement to use our system. People say, well, we don't have the budget to jump in and do this. Basically, what Ramic charges is an annual fee per asset and a one-time configuration or customization fee to get started. So typically, this is not a huge capital expenditure for the OEM. It's usually pulled out on an operating budget rather than a capital budget, meaning it's thousands of dollars, but not tens or hundreds of thousands. Measurable ROI, how do I get return on investment in my Internet of Things solution? Well, if you know the upfront cost, because we deliver a turnkey solution for a lump sum, now you know how much it's going to cost. Now we just have to identify how much downtime can we eliminate, or could we increase sales by 5%? It becomes measurable fairly quickly once you know the upfront costs, and we can help with that. Okay, the final topic I'll go through here is the Uberization process. And this is basically a process to determine what are the specific advantages of Internet connectivity and smartphone apps for your company. I like to step back and look at a taxi cab company. If we could go back 5 years in time before Uber and say, hey, we can provide this great smartphone app for your taxis, the objections would probably be things like, well, no, we already have a dispatching system. We don't have to order it via smartphone. We already have credit card billing. We have these credit card scanners in the taxis that don't work half the time, but they have a solution for that. And they, look, we're already leading our industry. We don't need smartphone apps. None of our customers are asking for it. And I bring that up because I do hear this from OEMs, and I understand. In many cases, people are not asking for this functionality. Yet, in many other industries, they are. And I walk product shows, and I see people already doing this. What happened to the taxi companies is they lost significant market share before they finally jumped on the smartphone bandwagon to some extent. And they're trying to catch up with Uber and Lyft, but they're doing it after they lost significant revenue. So you don't want to be the last person in. You don't want to be late to the table in leveraging the Internet of Things. If you look at taking a cab, the typical process, everybody's got smartphones. You probably Google the local restaurants before you call the cab company. But then you got to look up the cab. You got to dial the phone. You have to tell the dispatcher where you're going. You may ask what the fare is going to be, but you don't really know that up front. You don't know how long before the cab picks you up, so you're stuck hanging there waiting. And once you get in the cab, you tell the driver where you're going, and then you sit and you watch the meter ramp up, right? How much is this costing me? And then you got to deal with payment when all is said and done, either cash or dealing with credit card scanners. What Uber did is eliminate a whole bunch of these steps. Once you find the restaurant on Google, there's actually an interface so that you can click directly on Uber and say confirm, and then you got information exactly when your cab will get there, what the fare is going to be, etc. So how do we do this for a more industrial machine? I'll give an example of a car wash. What happens with a car wash if they run out of chemicals? Well, so the chemical level drops below some minimum threshold. They get a local alarm sitting there on a touch screen probably. Maybe there's a warning light that turns red. Eventually the chemical runs out if people ignore that alarm, which a lot of these are unmanned. The gas station attendant isn't sitting there looking for it. The gas station attendant may not care whether the car wash is running. That's not their revenue stream. So eventually the car wash shuts down, and the attendant will get enough complaints, and they'll finally call the car wash company. In the meantime, they've lost all kinds of revenue, the car wash has. So if you Uberize that process, you can monitor the chemical level remotely. Based on past usage, how much longer they're going to go before they run out of chemicals. And you can automatically reorder without having to pay expedite fees, because you know the lead time on your chemical order, and so it becomes a much simpler process and cost-effective. So how do you do this on your equipment? What we would ask you to do is talk to your customers, talk to any of your end users that interact with your machines or your equipment, and make a detailed list of the steps they go through during normal interaction, as well as the steps they go through when there's a problem. And if you detail those, list them out, you can start to look for ways to improve. And by all means, ask your customer, how could we do better? Because the remote connectivity and the smartphone apps open up a whole world of possibilities, especially when you consider that many of our systems are not just communicating dashboard information, they're tying into other software systems, billing, maintenance, et cetera, et cetera. So once you go through this process, and sit down with your Ramic salesperson, and we can help you analyze these list of steps and figure out, is there a possibility that remote connectivity can streamline this for you? And then that opens up the possibility of increased revenue as well as cost savings.